Vertical polarization, it's a topic here for Romania. We have this 4-panel configuration, steel spine, up to 660 millimeters side length, where you can easily climb through and do the maintenance also of the parts up of the antenna, for example, aviation lights or additional other antennas on top. Omnidirectional, or you can feed them with different power so that you can modulate the horizontal diagram as maybe the authority requested. Another one is the 8-panel configuration, also in vertical polarization. Here the mast inside is much broader, it's much more convenient to climb through. On the other hand, you can also modulate your horizontal patterns much more in detail. And everything can be arranged completely in the factory and will be then transported to site and with a crane or a helicopter put on top of the mast. Similar to the vertical polarization, we have this 4-panel configuration also for horizontal polarization. Here also maximum of 660 millimeters side length is possible. Then we have a solution for 5-panel configuration that could also be interesting for tubular masts up to 760 millimeters diameters, where we can arrange the antenna, the panels like this. We have a huge range of super turnstile antennas, horizontal polarized, omnidirectional diagram, from band 1 on the left side via VHF band 3 up to UHF on the right side. The right one is inside a fiberglass radome with a diameter of 1.6 meter. Interesting for this, if you have maybe an older antenna in a fiberglass radome and want to change to dvb-t or to dvb-t and you have other frequencies, or you have to realize other diagrams, we can also help you there. Integrating a new type of super turnstile antenna, or to put in panel arrangement so that you can easily create the horizontal diagram as requested. So if the fiberglass radome itself is in order, you don't have to waste it, we can put in new antennas. Super turnstile antennas in smaller tubular radomes. We have it from 500 watt now via 1 kilowatt, 5 kilowatt, 7.5 kilowatt, up to 50 kilowatt. So that means if you need gap fillers, then you take the smaller ones, or to cover a huge area, you can also take this 15 kilowatt, or to put more multiplexes to one antenna. Easy plug and play solution. On top you can see you can mount aviation light. So for maintenance you have this ladder on the side, of course not when you are radiating with this, transmitting with this antenna. And inside there is the cabling and the radiating radomes. Maybe some antenna panels that are not so well known here up to now. We have this slant antenna with different polarization, for example 80 horizontal and 20% vertical feeding. Then we have the elliptical polarization with 70% horizontal and 30% vertical. And then we have one panel where you can do it as you want, because you have one input for vertical and one input for horizontal. That means you can make a circular antenna, elliptical or slant antenna from this. Leaving UHF band, coming to band 3, I think for the future, if we have not so much space in UHF, maybe some operators have to go into band 3, not only for digital radio, maybe also for digital television, depending on the country. We have a lot of solutions also for band 3. One of it is, for example, this log pair antenna. You can use it for horizontal and vertical polarization. It has a very low weight and wind load. And you can, it's ideal for transmission along railways or highways or in tunnels. And it can be used for mixed polarization. Mixed polarization in digital is possible. For example, as you can see here, the right and the left part is vertical and the one in front and to the rear side is horizontal polarized. If you have huge buildings and the top is already occupied, then you can go to a lower section where you have a broader diameter. And with this arrangement, the diagram is nearly omnidirectional over the whole frequency range. So this is really an advantage also to use areas on the mast that you normally could not have used with analog technique. Because in analog it makes no sense to have dual polarized antennas there. Then we have panel antennas where we have one pair of dipoles with vertical polarization and one pair of dipoles with horizontal polarization. You can feed them separately so that maybe on the vertical part you can transmit a digital radio program, and on the horizontal part you can transmit TV program. This saves space on the mast and has very good results. You see both antennas are much better than with the VSWR than 1.2, so very good for digital transmission. Another thing, what is possible is VHF dipoles integrated in an FM antenna. This is an example of Norway. Also here you have over a huge band with very acceptable VSWR. This has some advantages, of course also some disadvantages. You need not more mast aperture on the mast, and these dipoles can be put in the panel also later. But the mast dimensions are not so suitable for VHF, so you have to make, the diagram is not 100% omni. You cannot use systems with FM systems with side shifting, because you can imagine that 300, 400 millimeters side shifting maybe in FM is okay to reach a good omnidirectional diagram, but in VHF it is not so good, so this cannot be used. But maybe there are some sites where you can use it. what you have to be clear is, whenever something of these combined antennas is out of order, then two systems are out of order. Yeah, if you have this VHF, UHF, if here something is out of order, both systems are out of order. You have to see this also. But normally you are buying very good quality and nothing should happen, so this should work. Another more complex system is multi-pattern antennas. We are also able to realize this. Here there's an example for FM, where you have different frequencies and different patterns requested, horizontal patterns requested, maybe close to the borders of your neighbors' countries. You have to fulfill one frequencies with lower power. Maybe you can transmit omnidirectional, but with a higher one you have to go omnidirectional, not to disturb your neighbors. This is possible. This is possible with full antenna operation, with half antenna operation, as you can see here. But investigations are higher, because you have additional combiners there. You have additional feeder cables. And in the transmitting hall, you need the space also for this additional equipment like combiner. And also the space needed is not for free. You have to calculate this, but very often it is the only possibility to make transmission with the existing sites. A small brief outlook. Of course, we are improving our antennas and all our products. We are looking for new developments in UHF antennas to combine the variety of different advantages of different antenna types into one panel maybe, and some other things. So that means you can be sure that next year we can tell you a lot of more interesting new things that we have developed and are able to bring into the market.